Okay, so we're going to look at another example of this Gaussian elimination. So basically, remember our goal is to get that triangular matrix from the augmented matrix, so from what you started. Okay, another way to think of it is, remember these two positions will eventually be what we call the pivot, and so you want to eliminate all the numbers underneath the pivot. Okay, that's another way to say your goal. Okay, so here's your starting equation. So write three planes intersecting at a point. We're trying to find that intersection point using this method. Okay, so the first step is to go ahead and come over here and write your augmented matrix, which again come from the coefficients of your equations. Okay, so 3, just kidding, -3, 2, -1, and then we can draw our line to represent that equal sign, and then we can put our constant on the other side, so -1. And then 6, -6, 7, -7. All right, and then last row, 3, -4, 4, -6. Okay, so that's our augmented matrix. And we're going to manipulate that so it goes into this, or gets into this triangular matrix format. Okay, so first step, we're going to start with this number as our pivot, this top left hand corner. So we're trying to eliminate the numbers underneath it to be zeros. Okay, so first, what I like to always get rid of this number here. Again, as you get better at these, some of you are already going to see right off the bat it's going to be pretty easy to get both of these to 0. So if you want to do it all over here before you rewrite your new matrix, that's fine. Okay, again, I'm going to break it down step by step so you can see what that looks like, but eventually we'll all have the same thing, even if you try to do those two things at once. Okay, so I'm going to work with row 2, trying to get this 6 to become a 0. So if I'm trying to eliminate the 6, right, using adding, subtracting, multiplying, okay, if I add these two, -3 and 6 right now, you don't get 0. Okay, so what that tells you is if it doesn't automatically cancel, you have to multiply one of your rows by something in order for that number to cancel. So I'm thinking if I can make this -3 and -6, -6 plus 6 is 0, and then that cancels, and that would replace that number with 0. Okay, so remember, we come over here, we make a little note to ourselves like what we're about to do. So if we multiply 2 by the very first row, and then we're going to add that to row 2, I want that to become my new row 2 because then that position would have a 0, and that's again part of my goal right here. Okay, so let's go ahead and multiply 2 by everything in row 1. So -3 times 2 is -6, 2 times 2 is 4, 2 times -2, or okay, 2 times -1 is -2, and then 2 times -1, again, -2. Okay, now we're going to go ahead and rewrite row 2 exactly how we see it, because we don't need to multiply it by anything. So 6, -6, 7, -7, and we're adding those together to get our new row 2. So notice the whole reason why we multiplied the top by 2 and we're adding them together is so that this becomes 0. That's what we wanted. Okay, that becomes -2, 5, -9, and that's my new row 2. Okay, especially if you're trying to do two things at once. Like if we came down here and automatically did our new row 3, you might just want to make your note to yourself which one's which. Okay, so I'm going to go ahead and not do them at the same time and just go ahead and replace my new row 2. So row 1 stays the same because it doesn't need zeros in it, so that's why we don't have to ever get anything to cancel up there. Okay, and then new row 2, so 0, -2, 5, -9, and then I'm just going to rewrite my third row. Since we haven't done anything with that yet. Okay, so we got 1 0 in its spot, so check there. Okay, so now let's go ahead and work down. We're still going down vertically, trying to eliminate these to 0 underneath this first pivot. So if I'm trying to eliminate this 3, notice through adding, subtracting, multiplying, I don't actually even need to multiply this one by anything, because right off the bat, if I were to add row 1 and row 3 together, this negative 3 and positive 3 will already cancel to 0. Okay, so over here, I'm going to tell myself, hey, if you just add row 1 and you add row 3, make that your new row 3, this position will become a 0, which is what we want. Okay? So, negative 3, 2, negative 1, negative 1. And then row 3, positive 3, negative 4, 4, negative 6. Let's add these real quick. So 0, again, whole reason we're adding them without multiplying anything to it, because it's automatically 0 when we add. Negative 2, 3, negative 7. And that's my new row 3. So now I can come over here, write my new matrix. So negative 3, 2, negative 1, negative 1, 0, negative 2, 5, negative 9. And then my new R3 goes in the R3 position. So 0, negative 2, 3, negative 7. Cool. Okay, so we have 2 zeros. Okay, we've eliminated all those. Okay, we've eliminated those numbers to be 0 underneath this pivot. So now we're going to move to this pivot and eliminate the number underneath it, and then we'll be good to go to create our new system. Okay, so here's our new pivot. So the number underneath it is this guy, and that's what we need to be 0. Okay, so notice if I look at row 2 and row 3, okay, that these are both negative 2. So right now, if we add those together, we would get negative 4 and not 0. So we could multiply row 2 by negative 1 in order for those signs to flip, and then positive 2 and negative 2 would cancel to 0. Okay, so over here in my notes, I'm going to multiply negative 1 to R2 and add that to R3 to make a new R3. Okay, if you wanted to do R2, like leave R2 the same and multiply the negative 1 to the R3, you're going to get the same thing. It's not going to matter. Either way, this position is 0, and that's what we care about at the end of the day. Okay, your new system would look a little different than what mine will, but mathematically it'll all work out to where your x, y, and z will be the same. Okay, so if your brain thought, well, I should multiply this by negative 1 and then add it to R2, that's fine. Go for it. Okay, do that, and then you can check your work with mine at the end. Again, our steps might look a little different, but the end result will be the same. Okay, so negative 1 to R2, multiplying each of those numbers by negative 1 would be 0, 2, negative 5, 9. R3 stays the same, so 0, negative 2, 3, negative 7. Add those, so 0, 0, negative 2, 2. And that's my new R3. Okay. So negative 3, 2, negative 1, negative 1, 0, negative 2, 5, negative 9, and then my new R3 is 0, 0, negative 2, 2. Okay. Something else I just thought of real quick is if you look up here, okay, the reason why I chose R2 and R3, you don't want to choose R1 and R3 on this, even though it might be tempting because the 2 and negative 2, your brain would think like, oh, that already cancels. But think about if you're adding, you're not just adding those two, right? You're adding all of the like numbers in row 1 and row 3. So look, if you go negative 3 plus 0, sorry, you can't see that, negative 3 plus 0, that's going to put this spot down here as a negative 3, and that like totally X's out what you already did, because now you don't have a 0 here anymore. You have a -3, even though you would have a 0 here, because 2 and -2 is 0, but that ruins this spot. Okay, so basically, once you get these two to be zeros, just work with row 2 and row 3, so then you don't mess up anything that you've already done, okay, by getting that to eliminate to 0. All right, so now we're here. We have our triangle formed with all zeros underneath it, so we're good to create a new system in order to solve our equation. Okay, so remember this is x, y, z, and then the number on the other side of the equal sign. Those are the coefficients. So we have -3x plus 2y minus 1z, or just minus z, equals -1. Okay, row 2, we could put 0x, but not necessary because 0 times anything is 0. So we can just put -2y plus 5z equals -9. And then last is -2z equals 2. Hopefully you're noticing I'm putting a line through my z's and not my 2, so you can tell the difference. Okay, so there's your new system that we're going to use in order to solve. And the nice thing about once we get it into that triangular matrix is now we can use reverse substitution, or kind of reverse substitution, I guess, where you solve for this bottom variable and you just go up, substitute up the ladder through all your equations. Okay, so I'm going to come over here, -2z equals 2, so that bottom equation here, and go ahead and solve for z. So z equals -1, and then we'll use that to plug into equation 2. Let's see if I have enough room to do all this. So -2y plus 5z equals -9. So -2y plus 5, we'll substitute in our -1 for z, equals -9. So -2y minus 5 equals -9. Add 5 over. I'm not going to write that step because I am running out of room, but when we add 5 over here, we'll get -4. Divide both sides by -2, and y would equal +2. Okay, almost done. You getting excited? Okay, so the last one is we take our y and z and plug it into this last equation here. So that -3x plus 2y minus z equals -1. So -3x plus 2 times 2, since our y value is 2, minus our z is -1, which equals -1. Okay, let's see if I can save some room here. So -3x, so 2 times 2 is 4, and then minus a negative makes a positive, so 4 plus 1 is 5, equals this -1 on that side. So when I subtract 5 from both sides, I get -3x equals -5 minus 5, -6. Oh, I'm barely going to fit it in here. Divide by -3, divide by -3, and x equals 2. Man, don't you feel accomplished? Okay, so last thing is write it as a point. So x, comma y, comma z to represent that point of intersection. So I'm going to come over here and do it since I have a little bit of room. So 2, 2, -1. That's impressive. Okay, cool. Hopefully you're getting the hang of it. I'm getting addicted to it now.